Hello friends, in this lecture we are going to study superposition principle, concept of interference and its two types, constructive interference and destructive interference. Let us first see statement of superposition principle. When two or more waves, either transverse or longitudinal, doesn't matter, but when two or more waves arrives at a point, arrives means comes together or overlaps, okay? When two or more waves arrives at a point, each wave produces its own displacement independent of the presence of the other wave at that point, and resultant displacement at that point is equal to the vector sum of the displacements of individual waves if each wave is present alone. That means y bar is equal to y1 bar plus y2 bar. Okay. Next to that, interference. The modification in the intensity of light due to superposition of two or more waves is nothing but interference. Modification means change, either maximum or minimum. Okay. Now it has two types, constructive interference and destructive interference. Let us first study constructive interference. And remember, this concept can be studied in case of both transverse as well as longitudinal waves. Here we are studying in case of transverse waves. Suppose a crest due to one wave coincides with the crest due to other wave, or when the trough due to one wave coincides with the trough due to other wave, constructive interference will take place. According to the superposition principle, the resultant displacement at that point is equal to y bar is equal to y1 bar plus y2 bar. That means a plus a is equal to 2a, and minus a is equal to minus 2a. Okay, that means amplitude becomes maximum, and you know that intensity is directly proportional to the amplitude square. That means I is directly proportional to amplitude square, that is directly proportional to 2a square. That means Imax is equal to 4a square. Hence, in case of constructive interference, both amplitude as well as intensity are maximum, and their values are plus or minus 2a and 4a square respectively. Now when crest due to one wave coincide with trough due to other wave, or trough due to one wave coincides with the crest due to other wave, destructive interference will take place. Again, according to the superposition principle, resultant displacement at that point is the addition of plus a minus a and becomes 0. Again, at this point, minus a plus a 0. Hence, in case of destructive interference, resultant amplitude is minimum and also resultant intensity is minimum. Understand? Our next point is amplitude of the resultant wave produced due to the superposition of the two waves. Okay. Now consider two waves having same frequency but different amplitudes a1 and a2, and having phase difference phi. Phase means state and state means magnitude and direction. Then at x is equal to 0, that means originally the displacement of the first wave is given by y1 is equal to a1 sine omega t, and the displacement of the second wave is given by y2 is equal to a2 sine omega t plus phi. Here phi is the phase difference between these two waves. Now when these two waves arrives at a point of the medium, due to superposition principle, we can write y is equal to y1 plus y2. After substituting respective values, instead of y1, a1 sine omega t, plus instead of y2, a2 sine omega t plus phi. Okay. Now here we can use formula sine a plus b, and it is sine a plus b is equal to sine a cos b plus cos A sin B. Okay, here instead of A we can write omega t, and instead of B we can write phi. By substituting these values we can write y is equal to A1 will remain as it is, sine omega t is also as it is, plus A2, and here by using this formula we can write into the bracket sine instead of A omega t and cos instead of B phi. Similarly, plus cos A means omega t into sine B means phi. Okay, now look at these first two terms. From these two terms we can figure out a common factor, sine omega t. Then remaining terms inside the bracket are A1 and A2 cos phi. Okay, now second term will remain as it is, plus A2 into cos omega t into sine phi. Okay, now let us make some substitutions. Instead of A1 plus A2 cos phi, let us substitute A cos theta. Suppose this is equation number 1, this is equation 2, and instead of this A2 and sine phi, let us substitute A sine theta. Okay, now after substituting equations 2 and 3, in equation 1 we get y is equal to sine omega t will remain as it is, instead of this bracket A cos theta plus cos omega t will remain as it is, and instead of A2 sine phi, A sine theta. Okay, now here again A is the common factor. Inside the bracket sine omega t into cos theta plus cos omega t into sine theta. If you look carefully, sine A cos B plus cos A sine B means again you can make use of this formula sine A plus B. Here omega t is A and theta is B. Therefore y is equal to A sine omega t plus theta. Now this is the equation for resultant displacement of the wave, and here A is the resultant amplitude of the wave produced due to superposition of two waves. Okay, here we can find value of this resultant amplitude with the help of these two equations 2 and 3 by squaring and adding. Okay, now squaring and adding equations 2 and 3, we will get that means we have to square and add both the equations at a time. Let us first make a square of the RHS of 2 a square cos square theta adding RHS of the 3 a square sin square theta. Now look at LHS. Squaring this term, we will get a1 plus a2 cos phi bracket square and plus LHS of the equation 3 a2 sine phi, and its square is a2 square cos square a2 square sine square phi. Okay, now a square cos square theta plus a2 square sine square theta is equal to a1 plus a2 cos phi bracket square plus a2 sine phi bracket sine phi square. Here we can figure out a square as the common factor, and sine square theta plus cos square theta is 1. That means a square is equal to, now treat this term as a plus b bracket square. You know that a square plus 2ab plus b square. Okay, a1 square plus 2a1 a2 cos phi plus a2 square cos square phi, and plus this will remain as it is, a2 square sine square phi. Here we have used formula a plus b bracket square, a square plus 2ab plus b square, and this term is as it is. Now look at the last two terms. Here again a2 square is the common factor, and sine square phi plus cos square phi is 1. That means a square is equal to a1 square plus 2 a1 a2 cos phi plus a2 square. After taking square root on both sides, a is equal to under root a1 square plus a2 square plus 2a1 a2 cos phi. Now this is the resultant amplitude of the wave when two or more waves interferes with each other. Now we can see two special cases. Case 1, in which both the waves having phase difference 0, that means phi is equal to 0, therefore cos phi, that means cos 0 is equal to 1. If we substitute here 1, then this term will be a1 square plus a2 square plus 2a1 a2. This can be treated as the expansion of a plus b bracket square. That means a is equal to under root a1 plus a2 bracket square. This square and square root will cancel each other, and now a is equal to a1 plus a2. Now if both the amplitudes are same, that means a1 is equal to a2 is equal to a. This a plus a will becomes 2a. Okay, that means a is equal to 2a. Amplitude is equal to 2a. Now in case of anti-phase waves, that means when phase difference phi is equal to pi, cos of pi is equal to minus 1. If you substitute minus 1, then this term will be a1 square plus a2 square minus 2a1 a2, and this term can be treated as the expansion of a minus b bracket square. That means a is equal to under root a1 minus a2 bracket square. Again square and square root will cancel each other, and a is equal to now a1 minus a2. And if both the amplitudes are same, a1 is equal to a2 is equal to a minus a will be 0, and resultant amplitude is 0. That means in case of constructive interference, that means when phase difference is 0, the resultant amplitude is maximum, that is plus or minus 2a. And in case of the destructive interference, that means when phase difference is pi, the resultant amplitude is 0. Understand? Thank you.